One thing to mention here is that the exam we uploaded on our content library of our notebook. That's exam one. Yeah, I probably should remove this file. Let me try that. Let me think. Well, yeah, let me not remove it. So basically, here, this icon right here is actually a file that you can click and download. So that's usually the case. If you play with this notebook often, then you will see. So if you want to utilize the file and use it as a future preparation material, that's totally fine. So okay, question one. Analyze the Python code cell below, provide the output of the cell if it's bug-free, write down the issue of the code, and you'll fix if the code is bugged. Uh, so basically, the thing is, when I designed the question, so let me zoom up a little. So when I designed the question, I sort of gave a little bit of a tricky thing within the definition because I changed the number n less than one right here. So I think in the earlier implementation in our countdown in the live coding session, I had it n equal n less than zero. Okay, so basically, if your input number for the countdown is less than zero, as a negative integer, then you will get an error. But then when it's zero, you're gonna get blast off as a string. When you get n that's larger than zero, then you will need to count down. So string of that number, and then dot dot dot, and then you go to the previous countdown. So basically, if you have so when you have a blank of no arguments, it tells you your default n value is 3, and then you just start from there. So this is like a recursion, right? So essentially, make sure to think about this in a really systematic way, like interpreter does. So essentially, you have what you will have a basically you will return a this is going to be a string. Okay, so when you run this line, it will give you the string of 3 dot dot dot, and then now we get to count down n minus 1, which is a countdown of 2. Okay. And then when n equal to 2, we just make sure to check everything. So the first if condition is going to be false. So it's an integer and it's larger than 1. Okay, greater than or equal to 1. Okay, n is not 0. So the second if condition is also false. Then we get to the last one, which is a string of the input, which is 2, and then dot dot dot. Make sure to have the dots. And then we get to what? We get to countdown of 1, right? So n minus 1. So is a 1. And now think about this. So I made the change that I circled on the top. So it may give you something that's not really blast off. So now you have what? We have n equal to 1. Okay, so n equal to 1 is still fine. So we have the first if condition is false, right? And then the second if condition is also false. And then we have 1 dot dot dot. Okay, so now we have countdown of 0. So this is something that I changed, but when I graded, I forgot. So countdown of 0. Okay, when n is 0, it's the n is less, just 0 is less than 1, which is true. Okay, so the first if condition is true. So essentially, you're gonna return that long string. Okay, so this is a modification. If you really think about it in a interpreter strict way, then you would end up with error input should be and then just continue with the rest. So this is if I had n less than 0 right here, okay, this is a highlight. Okay, so n less than 0, then the final output is the old one, which is 3, 2, 1, then blast off. Yeah, that's the old countdown function that we have written. Okay, but this one I slightly modified the circled part. So the perfect answer would be this one. Okay, but yeah, well, just to point out, I don't think I gave any deductions. If you just write 3, 2, 1, blast off. Okay, but just make sure that be strict about the output of your string, because indeed you are just piecing those parts of the strings all together, right? So the string of the number and then the dot dot dot, okay, and then following with the rest of the things. So that's good. So yeah, so this is a modification that I did when I graded. I forgot. Okay, so but yeah, well, it's just so you know. But this is the type of question that I may give you in your coming up quizzes and in the exam, right? So I'll give you something that's sort of reasonable, but you still need to think through carefully. Okay. All right. Question 2. Analyze the code cell below. The purpose is to generate all permutations of an input list without repetition. So here, just as a reminder, when we talk about the repetition, that issue, basically we're saying, okay, the list may have repetitions, okay, but for permutations, you don't really want you don't really want the permutations to have repetitions. So that's what we mean by saying without repetition. So essentially, this is something we discussed in class when we talk about our implementation for this particular kind of question. So here, provide the output of the code if it's bug free. Write down the issue of the code, and you fix if the code is bugged. So here, if you look at the code that we provide, actually it's not bugged, but it doesn't serve the purpose. Okay. So what does it do? So you have an X, right? It's a list. And basically the first step is you just sort it, okay? So this is sorting. So let's see. We have A equal to 1, 2, 1, right? So now let's run this this code. Okay, so 1, 2, 1, the sorting will give you 1, 1, 2. Okay, so that's what I get after doing the sort. And then my list is essentially the output that I want to accumulate. Okay, so it's the list of lists. Okay, it should be the list of all permutations or permuted lists. Okay. And then now, depending on the length of my original string, I would then give different kinds of outputs. For instance, if there's nothing, okay, if the length of the input is 0, then of course there's not going to be any permutation. So I'm just going to return the my list as the empty list. So there's nothing there, right? So this is empty list. Okay, so empty list because there's no permutation there. Okay. And let me zoom up a little. And now if well, when the length is 1, okay, so if there's only one element, then let's say you have 10, and then the permutation will just be itself. So there's only one element in the list. So we just append that itself, okay? We just append itself, and there will be one element, okay? One element in list. So that's also serving the purpose, right? But then we need to, because this is sort of like a recursion, so you do need these like ground cases, okay, just the fundamental cases for you to build up your recursion. So now what else? So if the thing is longer, right? So let's say we have 1, 1, 2. So what do? So basically you pick the first element, you put it on the side, and then you just permute all the rest of the elements, and then put it after your first element, and then you just append. So that's the idea here. So basically, you see, so that's 1, 1, 2 that we have, right? So you have what choices? You have you pick the first element, and then you put it on the side, and then you permute 1, 2, that you take away. So that's gonna be 1, 1, 2, and 2, 1. Right? So that's what you have to do, right? For isolating the first element, right? And then you're gonna go with the second one. So that, but still it's a 1. So if you do it systematically, it's gonna be still be 1, and then the rest of the two are 1, 2. So it's gonna be the permutation of those is gonna be that. And finally, now we have the two there, which is you want to isolate, and then for 1, 1 you permute, and for 1, 1 you permute. Still, there are two elements. So if you don't handle the repetitions, then it's going to be 1, 1 treated as different elements, and then the swap. You do the swapping. So essentially, it's going to be 6 elements in total. So essentially, your code want to mimic this kind of behavior. So that's what the for loop here does. Okay, so this is now else. So for I in my in the range of my length x, right? So basically, this is just saying this is the index running all the way, right? This running down. Okay, running down my list x, right? So now here, I see a problem. Okay, so now let's run the code. Let's run the code and see what happens. So here, there's a problem. When you think about it, okay, so you have a list, okay, but then what you want to do is you take one element, and then you have the remainder list to be permuted in the recursion. So that part is done by the pop. Okay, so this pop I is saying I take away the ith element. Okay, so this pop ith element, and then that will be stored as my first element. Okay, so that will be this one. And then now remember the pop operation does what? This it gets rid of that ith element within the original. So that changes your original data. Okay, so the temporary list is now modified. Okay, it's shortened. So that's something really special. But here, notice this is temp equal to x. That's not a shallow copying. That's something not good. Okay, so that's an issue here. There's a problem. And let me take a look at the examples. Carefully look at what I designed for. Okay. Yeah, right. So that is temp equal to x. Okay, so yeah, let's look at the code. So this is a problem. So you want a shallow copy. You want something like this. Okay, so there's an issue. You want temp equals to x colon. So that's shallow copy. Let's make it a separate copy. So if you just do temp equal to x, then when you pop I from temp, then your x list is also modified. Okay, so that's a problem. So that's a bug. And then what you do here is now, okay, I permute. Now you see here, this is permuting my reduced shorter list. Okay, and then once I do the permutation, every time append the first element with the remainder permuted thing. So that's appending this to this and this to this, right? So that's what it does. And now for every element, for every I, I'm gonna get that two appended permutations within my list. So that's essentially what we need to implement. But indeed, there's an issue. So yeah, let's also make it run on my web page. So let me see if I have it here. Okay, okay, that's fine. Okay, let me try to find it. Where's my class here? Uh, quiz and exam and exam. It loads. And also, let me share the screen from our side. Okay, it's frozen. Mm, so yeah, right. So running this, okay, so that indeed will give you that n less than one. That will, okay, so now that works. Okay, so let me share the screen here. Not responding. Sure. Right. So okay, so now let's run this and see if there's any issues. So that's this is another copy of the output for me to make the space. Okay, you see this is a problem. Okay, so here now basically every time when you do the pop, it will reduce the length of the list. Eventually, it will be empty, so you will not be able to pop it further. So that's why there's a highlight for the issue. So here it says pop index out of range. Okay. So that's the problem here. So make sure, okay, make sure you need a shallow copy so that you don't modify your original data when you're doing the pop. That's very important. Okay, so that's shallow copy. I do the copy. So remember, this is like one liner of copying the list that we have introduced. Okay, so if you have colon -1, that's saying I not only copy but I also reverse, right? So basically, this is the slicing. Yeah, that term is slicing. So we do need this to make it run, and you see the output. Okay. So right. So here in this code, I don't really have any prevention of repetitions. So that's exactly 112. So I picked the first one. So 112 after sorting, right? I pick the first one and I permute the rest. That's 112, 121. And then now the second one is going to be selected. It's going to be 112 and 121 again. And finally, the two there. I picked the two, and then 1 is now treated as two different elements. So that's six copies of things, which there's an issue for repetition. Okay, are we all good? So yeah, well, so I well, so I think for this question, the bottom line here is to make sure that to know that this is not serving the purpose of no repetition. Okay, but then I would say this is sort of like a bonus point that you sort of need to uh, identify so that in the future there's no bugs when you're doing this kind of stuff. Just remember whenever you are doing this kind of attributes, okay, for your list, you make sure to keep a copy of your original data so that you will not mess things up. So that's very important. All right? Make sense? Um, yeah, well, if let's say in the final exam, if this question reappears, then I would expect you guys to identify both issues. One is that it doesn't prevent repetitions of permutations, and you do need a shallow copy. Okay, you do need a shallow copy for this. And let me change it back. So there's a bug, right? So yeah. Okay, so now let's go back to our wait. Let's just scroll down and see if we find it necessary to go back to the notes. Yeah, this question is very important. this one I would say, well, if you have, yeah, well, yeah, there will be many ways that you can code to get the data from a string and then add the data. Okay, so there are many ways, but the one way here that we're doing in a really fundamental sort of the build up is so that in the future, if you have kind of mixture data and you want to run through, right? So you do need the mechanism to identify what you want to keep and what not to keep. And then for things that you want to keep, you have some basic manipulations. So this is sort of like giving you the mindset. Okay, so for things that you are currently dealing with, you need to keep sort of like local copies, and then once you're done, you will refresh the local copy. Okay, so that's the main idea. So, mm, so yeah, let's switch back to our notes. So I would say, once again, this is the temporary digit copy. Okay, you want to accumulate. So which is that token. So basically, whenever you are not at the uh whenever you're not at the colon, you want to keep accumulating, right? So basically, this is like one, and you want to get to 1 point, and you want to get to 1.1, and then stop. Okay, so that's the idea there, because there's you can accumulate the period, but you don't want to accumulate the colon there. Okay, so stop because of that colon there. All right. So that's our token. So what you want to do is basically for the things that you stored before, you want to add your current character. Okay, so this is token plus character. And then else, okay, when you hit the period, excuse me, when you hit the colon, then now you don't really need to keep on accumulating these digits. Okay, so then you just convert it to a number and then you add. Okay, so it's going to be this line. Yeah. So my recommendation here is that let's suppose this thing reappears in the final exam. Then my recommendation here is that you can just put down the code in your own code cell and then play with the way that makes it work. Okay. So that you can get a better more solid understanding of this. So here notice that these numbers have really nice formats, right? So it's just A point B. It's like 1.1, 2.3. But of course, if you this thing we write it in this way so that if you have longer digits or different kinds of digits, it's still gonna work. So if you have like 0.1295, uh, um, and then just 0.11338, and then 123.25. So this thing still can work. Okay, so it doesn't uh so well, it doesn't matter what format of the digit number is, so that still can perform well. So that's the upside of this kind of implementation. Okay, so it's all right. Mm, so yeah, I would say reading and constructing your own for loop in a basic way and bug free. That's like the first thing that you want to take away out of this course. And of course, there are other methods that you can improve your code, but that's something that you can do once you're getting more and more experienced. Right? But so far, let's just make sure we can do this. That was good.
So the string, anything within the string is considered as a character, right? Anything,
Yes,
including the space.
including space. Including space.
If I store the token, let's say I want the end result to be a float, can I just say, because token just will have numbers and just the integers and not numbers, can I just say token convert token to now floats?
Yeah, that's this line right here, right? So yeah, you keep on accumulating. So what I'm saying here is, okay, you have 0.1295. You first you read 0. You want to keep on reading. It's 0 point, and then keep on going. So 0.1, and then 0.12, and then these are all strings all the way up to 0.12595, and then you stop. And then here you convert it to a float. Yeah, you definitely want to convert to a float and then add, right? But then still you need to get to this point. Okay. So this is basically what you are doing when you're running through the string. Okay, so every time you have one more character, then how you're gonna handle that character, the new one, right? So you get
when the number 1, the last digit,
the last digit of here, or you mean here or where?
0.1295.
5. Okay, here. Okay.
Sorry, yeah. So the last digit is 5. So once I hit the last digit, I then convert the entire thing to float
Right.
for the operation to identify it as float.
Yes. And add total. Add to total, yes. Yeah, so that line is the same as the line at the bottom, because in the end you don't see a colon. Okay, so that's why. So now at your last character, then you just convert your the end token, and then to get a number, and then add, and then done. Yeah. So that's good. All right. Well, okay, so question 4. What's question 4? Please complete the code below. This function, if it's prime, that takes an integer n, returns whether this is a prime or not by recursively checking divisibility by integers 2 through square root of n. Then predict the output below. So yeah, well, here basically we're asking you to determine a number whether it's a prime or not. Okay, so this is like the recursion implementation of this if is prime function. Just remember earlier we had the for loop that you divide all the way through, just dividing by 2, 3, all the way up to that I squared less than n. So it's something like that, right? So, but here we're doing this kind of recursion. So what does it mean? So basically, when you divide by I, you are not sure. You want to keep on dividing. So you now divide by I plus 1, then I plus 2, all the way up to this point, okay? So now you are dividing by some number that's, you're trying to divide if it's, if I squared is now larger than n, but you don't need to do the division anymore, because now I is already larger than the square root of, I is already larger than the square root of n, so it cannot be a factor of your value n. So that tells you what tells you. So here well, I'm kind of expecting this to be a true, right? So this is now indeed a prime. So this is basically saying at this point we have this is have divided divided 2, 3, all the way up to let's say square root of n with a floor, just the largest integer less than or equal to square root of n. So we have already divided these numbers. Okay. So but then the ceiling is too large. So we have already divided these, and every time we have what? We have uh so we keep on referring to the last one. So now everything runs through. So you are not getting division. You're not getting a modular of a zero. Okay, so that tells you you are indeed a prime. Okay, so that's a true. But of course, if you say this is a string of is prime, then that's totally fine. Okay, so as long as it's reasonable, then. Okay, this is a spam call, which is right. Okay. So yeah, if you return a string of like is prime, then that's fine. I wouldn't say that's wrong. And then what else? If you are dividing I, but you get a zero, it tells you this completely divides. It tells you I is a factor. Okay, so this tells you I is a factor of n. Then you don't need to go further for the division, because now you have a factor which is not a two, okay, not one, right? So it could be two, it could be three. So that tells you this is false, okay, not a prime. So or you can say not a prime. That's totally fine. But your answer should serve the purpose, okay. And then when n equal to 2 or 3, okay, so we know 2 is a prime, 3 is a prime, so you should say something like a true, or should something like a prime, okay, is prime. But basically here the first condition, when n is less than 2, meaning what? Meaning n has to be something like a 0 or 1. In that case, we consider them as not prime, so that's sort of like a hint that you want to return booleans, okay? But if you return strings, that's reasonable. All right. Okay, so, and of course, now for the answers here, this will call this part, okay? So that's a false. So n equal to 1, so we get we get to the first return. All right. So when n equal to 3, we actually get into the second. So that's really gonna reflect on your answer here. So it's really these two. Make sense? And it's primes of 6, right? So, well, that's kind of obvious answer up to your knowledge of prime numbers. So 6 is not a prime number, right? But then that's really up to something like this. So you are essentially dividing, let's say, by 2. Okay, so I equal to 2. You divide by 2, and you get a whole number. So that tells you you need to return either false or not prime. It's really up to your design of the function. Make sense? Okay, so yeah, well, just be careful when you code when you are interpreting your code. Question 5, analyze the Python code below, provide the output of the output cell if it's bug free, write down the issue of the code cell if it's bugged. Oh, this is the shorthand. This is like a sh shortened function name for the Hamming distance. So you are looking at the strings S1, the strings of S1 and S2, and what does it do? So basically, you're saying, okay, I look at the length of my S1. Okay, so length of S1. So this is running I from 0 to length of S1 minus 1, right? So basically, you're just running through your first string, okay? So this is running through. Running through. And you're saying, okay, if the i's character is not the same, okay, for S1 and S2, then I'm gonna add a counter to by 1. Okay, so basically you're just counting how many characters are different. So now for these two, so these two are the same, and these two are the same. L, C and C, L and L, and U and O, that's 1. E and U is 2, and then it stops. Okay, because that's my S1. So basically, your I goes from 0 to 3, and then you stop. So that's gonna be a 2, right? But then there's gonna be an issue for this part, because now when you get to D, we're at the index 4. Okay, 0, 1, 2, 3, 4. That's the index 4. But here there's no index 4. Okay, no such index. So indeed, there's gonna be an issue. Okay, but of course, when you call the function the first time above, then there will be no bug because your S1 has a shorter string. But now in the second one, you have a bug. Okay. So length of S1 is less than larger than length of S2. So S2 index out of range. Okay. In the loop. Okay, so that's the issue there. That's good. So yeah, make sure to think really systematically. So so you wouldn't be too bad. So okay, question 6. Analyze the code cell below designated for bisection search. Okay, so bisection search. So remember what bisection search does. So basically, you have an interval, you have some number in the interval, and then what you do here is every time you cut the interval into 2 pieces, and then you want to see if your cross is in the interval on the left or on the right. And then you know if it's on the left, and then you keep on bisecting the one on the left, and just keep on doing it, right? So what's the bottom line? The bottom line is that your interval must contain the guess. Okay, so the left bound must be your less than or equal to your true value, must be less than or equal to the right bound. If unfortunately your interval is here, but your true value is here, then bisection doesn't do anything. Okay, it doesn't help you at all. Right? So you keep on doing the bisection, and then bisection. It just keep on getting closer and closer to the left endpoint, but not really getting close to your true answer. Okay, so that's the problem. So that's the problem in our code that's presented here. You're getting the here. This is the cube root function, but yeah, well. So just not be confused with the name. So you want to get the cube root of negative 1/8. Okay, so this is negative 1/8. So that should be negative 1/2, but it's negative, right? And what's the problem here? The problem here is your left bound is 0. The right bound is negative 1.25. So this is already an issue. Okay, so you have a left bound which is larger than the right bound. Okay, so now you have a 0, and what's your guess is so let's say this is negative 1/2. This is negative 1/8. So you see the problem, right? So your guess is this location. Excuse me, the true value is this location. Your left bound is is larger. Your right bound is less, and they are not enclosing your true value. So it will be an issue there. Okay, so that's the bug. And does it run? Actually, no. Okay. because once again, your right bound is negative, your left bound is 0. So this thing in the while loop is going to be a negative number. So this part, it will be a false. Okay, so it will not be larger than epsilon. And your guess, so one part is false, and the while loop will not run. Okay, so you actually will not get into this while loop. Make sense? Okay, so here basically you're saying, okay, if the approximation is bad, then I can keep on running, right? But now you're saying, okay, for this part, essentially you're saying if my interval is short enough, then I can stop. But now you have a negative number which prevents the while loop from running. Okay, so this never runs. So loop never runs. So that's the issue there. And of course, you can say, okay, the easiest way to fix this bug is to make sure that your left bound is on the left of your guess point, the right bound is on the right of the guess point. So you can say one way is to make it -1, one way to make it like a 0 also. Okay, so -1 and 0, right? Wait, yeah, so that will include your -1/2 as something in the middle. Okay. Now x can be also the right bound, so that's fine. So yeah, there are many choices. All right. Okay, so yeah, that's this problem here. Yeah, bisection is indeed very important. So we're not really sure what kind of computational tasks that you're going to play with in the future. But let's suppose you would have to solve some equation, okay, get some solution out of the interval. Then bisection is a very helpful technique because the convergence is actually linear time. So you just need log of epsilon iterations to get you the true answer. Okay, so that's nice here. Question? So what? Question 7. Please complete the following code. It should reverse any input string. Okay. So to reverse the inverse string, we know that there's a slicing trick, right? But that's not what we're asking. So essentially, let's see. Okay, when the length is 1, I return the original string. There's no issue. This is the baseline, the base case. But then when you have longer strings, you would, let's say, put the first string at the end, all right? And then for the rest of the thing, I do recursion, or I put the last character up front, and then I reverse the remainder string. So that's gonna again the recursion. So either way is fine. So it's, let's say, as of -1, okay, plus reversed as of all the way to -1, okay. Or I can say I put the first index, okay, first character at the end, and then for the rest, I'm gonna reverse using this kind of recursion. Now this is starting from 1 all the way. All right. Either way is fine, right? And of course, I think for the answer, you just need to predict the reverse of the string hello world here. Oh wait, no. So the input here is this string, hello ABC. So indeed, you just need to reverse the string here. So that shouldn't be an issue, but to make sure you do it systematically. There's a space, okay? CBA space OLLEH, all right? So, all right. Okay. So yeah, so here the purpose of this answer is to make sure to identify that your input is different from the default. Okay, so different from default. From default. Okay, the last one, the extra credit. So although the statement is pretty lengthy, but just remember what we want. We want to approximate the number e, right? And then what do? You just utilize the first n terms. Okay, so when n equal to 0, you are actually looking at the index 0. There's only the first one there, index 0, and that's my index 1, and then index 2, and then index 3, just basically picking up the indices from 0 to n. Okay, so you're just adding up those terms. And do you need to worry about the power of 1? Actually, no, right? Because for each of these terms, that's just 1 over factorial of n. All right, so that's that. So if you seriously think about the sum, so once again, when n is 0, you return 1. What's that 1? That 1 is here. When n is 1, you are picking up the zeros index and the first index, all right? The 0 index, the 1 index. And when n equal to 2, you are picking the 0 index, 1 index, and 2 index. So basically, it's just the for loop where your index goes from 0 to n. Okay, so that's right here. Okay. So index from 0 all the way to n. Okay. So indeed you're just adding these 1 over factorial. So and then to predict partial E series 3 is actually the first 4 terms, 1 plus 1 plus 1 half plus 1/6. Okay. This is 2 and 3 2/3. So yeah, so the last question is not necessarily the hardest one. So make sure to play with it so that once you get it correctly or partially correct, then you may have a significant addition in the scores. So that's good. So yeah, just I would say, well, in the coming up quizzes and the final exam, I would say the styles of the questions will be highly similar. So I may give you this kind of code cells for you to identify certain really important features that we are covering in the class. And well, you may still see things from the lectures and things from homeworks. Okay, but now we are getting into object-oriented programming, so that's a little bit new. But indeed, there are certain subtleties that we need to also face. Okay, for this coming up material. So these are, I would say, important, but also fundamental things that you need to take away out of the course. Any questions? All right. Yeah. Okay. So now, these are the notes that's gonna still be shared in the quiz and exam section. Okay, so just make sure to go back to it and if you want to do reviews. So now let's continue. We are okay, we're at lecture 7. So where were we? Okay, we were talking about lambda functions. Okay. Mhm. So what are these? Lambda functions, they are special functions, in a way that you do not specify the name of the function anymore. Because sometimes your function defined is only utilized really locally. It's going to be utilized right there when it's defined, but it's not going to be called elsewhere. So sometimes you just have certain operations that you need to do and then done. So then you want to make it this simple so that you are doing the variable binding, and then you are doing this kind of calculation, but nothing further. Okay, so if that's the case, then this is the way that we're doing this kind of like one-liners, right? So we're doing this comprehension. We're also doing this kind of lambda function so that everything can be condensed. So one example is the following. So we are talking about this kind of operation. So let's quickly be reminded that we are doing this kind of operation. Let me make it purple. Okay, so ddx, okay? ddx is the differentiation operation. In the mathematical sense, this is not really difficult, but the idea is very important because we have a function, okay? It can be a polynomial, it can be something really weird like sine, but then the differentiation gives you the derivative function, which is another function. This is mapping from one function to another. So this is if you want to call it in the mathematical way, this is kind of like the functional operation. So you are giving function inputs and function outputs. But in terms of codes, we would want numerical approximations to make it simple. Okay, so just make the computation simple. So what does it do? For a function, we specify f of x. Okay, this is just x squared. But now that's a function name f, right? Here, so on the top, the derivative is representing this kind of mapping of function, okay, from the original function to the derivative. Okay, so now the derivative of f we calculate it in this way: the slope of the slope of the secant. So this is the slope of the secant right here, right here. Okay, so we're just using the change in the output of f over the change in input, right? So dx is the tiny little change in input. X is the input of x is lambda. Okay, x is that symbolic variable there. Okay, so that's the input. So what does it mean? It means here it means ddx of f is defined as f of input plus delta minus f of input over delta. Okay, so that the x is delta. That lambda x in the front, that's specifying the way that you are basically defining your function. Your input is x, your output is that fraction on the right hand side, and that input is there. That's the dot. Okay, so if you're comfortable with the dot notation for the argument, because so that's my lambda x. Okay, so that's argument. Right. So So the bottom line here is that this fraction, this kind of way that you define this function, is not going to be utilized anywhere. That's callable. Okay, so you're not really defining it in a definition, blah blah blah, functions return. So you're not really doing that. You're just doing this kind of one line definition of the division here, right here. Okay, so. So that's that. Okay, so that's that. So in the mathematical sense, indeed, you're just doing this kind of one-line definition. So that's exactly how this is done right here. Okay, so yeah, let's play with this kind of computation in our code. In the code, let me close this. And what? Okay. Okay, here. Let me scroll. Okay. Is it? Okay. Yeah, okay, it's sufficient large. So let's run. So what do we want? We want to calculate what this is the derivative of f, right? So the derivative of f is saying, okay, I'm not getting the wait. So here, derivative of f. Okay, so that's this. So we have a function f. That's f is the name of our square function. Okay, that's right here. So now the derivative of f is essentially the way that you are returning a function. Remember, your input is x. Okay, your output is that fraction there. Okay, as a what's called a derivative function. So if you look at the type, okay, the type of derivative of f is a function. Why? Because this is a function. Okay. So that's the bottom line of this code. And what does it do? So let's hide this line right here. So to comment it out. So we are trying to approximate what f prime at 0.5. Remember, the derivative of f here is really simple. X squared, the derivative is just 2x, right? So 2x now, if your input is 0.5, then it's 2 times 0.5. So the derivative should be 1. But here we're using this kind of really second line approximation. So this is indeed a little bit off. Okay, so we're saying, okay, the change in x is 0.001. So indeed your error of derivative is also in the order of 0.001. And what do you think about this long decimal number of error here? So why do you think this could occur? This is like 9999, a bunch of nines, and then 741. So why do you think that's different from this dx value? So actually, that's because of the round-off error for your decimal number. So remember, we mentioned a little bit earlier that 0.001 is actually what? It's actually 1 over 1000, right? So this is actually not a finite decimal number in the binary. So when you store this number here in float, it will be an error here. So basically, when you do this kind of computation, you specify x to be 0.5, right? So x is 0.5, then that's gonna bound to this is 0.5 plus dx 0.501. That's your function value here, and then minus f of 0.5. So that will give you some calculation error within this fraction. So indeed, that's gonna give you something just off. Okay, so but that's the idea there. Okay, so here basically we're using this kind of approximation So there will be some inaccuracy, but the idea is that this is indeed a function. Okay, the derivative of f is indeed a function. Okay, so we have of f as a function. The derivative now is indeed a function, so you can plug in a value using brackets. Okay, so that's the utilization of this lambda expressions. Okay, and once again, it's going to be a function type. Okay, so a similar example is this one. So now here you can use this one line to define the output of x times y times z when you're given x, y, z as the arguments. But here we now give it a name because remember the right-hand side is a function. So here we call this function h. So when you are trying to call this h of 2, 5z, so that's essentially binding 2 to x, binding 5 to y. So essentially this is 2 times 5 times z. So that's indeed a function. So here this is, so now if you specify that to be g, then you have another function, univariate. Okay, so, and now, yeah, let me hide this part. So indeed, g of 9, you can expect it to be what? It should be 10 times 9, which is 90 indeed. Okay, and then the type of g is an integer. Of this g of 9 is an integer. But what about the type of g? The type of g is what? This is indeed a function. Okay. What about this? 2 of y's. So what about this? Name error. Y is not defined. Yeah, let's okay. So this avoid that. The z is not defined. So yeah, so what's problematic about Python sometimes is that okay, for whatever language that you have, it's always going to be this. If there's something undefined, then it's going to be an issue. So but here, okay, g is a function, so g of 9 is an integer because this is specified as an output. Right. Okay. So that's good. So yeah, lambda here is exactly one line of defining a function. Okay, so that's something that there's a handy trick. Okay. Okay, so now map list function. This is basically mapping a list. Okay, so you have a function and you have a list. So you don't really want to write for loop to pass all the list values to the function every time. That's going to be inefficient. So the way they do is they use the map function, okay, to take in a function and the list so that it will just map all the inputs of within the list to the output of the function evaluation. And then, but still, you need to put them together in a list. Okay, so here the example is the following. So I have a list, and then let's just look at this line. So here the test, this test function is something else. So a new list is what? Is basically I'm saying I do lambda x mapped to x minus 200. That's what. Let's say I have a function. For every input x, I'm subtracting 200. So that's my rule. Okay. So now I'm just applying this function to the A list. So you can expect that you're going to get 1 minus 200, 14 minus 200, all the way down to 10 minus 200. Okay. So now let's print. So let me hide these code, and I'm gonna print. Okay. So let me just run. Okay. So yeah. So once again, you have some function. If you want to write a for loop, it's going to be quite a few lines. Okay. But now you can do map of the function supplied with that list afterwards. So that will give you this kind of mapping. But still, the data structure is not a list, so you want to also convert it to a list. Okay, so that list, the bracket the list is right there. Is for that purpose. And finally, you will get this mapped list. Okay, so that's a bit. So now let's get the B list. Okay, so the B list is another thing. So here our test function is now 2 times x. So basically here you can say, okay, I define a function. So if the function is defined, right, this is test f, then now you can just use the function name to supply as the function, and then you have the A list. So one way to get the output list is basically map the function with the list, and then you convert it to a list. Okay, so that's the B list. And now, if you are doing list comprehension, okay, so if you're saying I do test f of x for all x in A list, that's also one line. So essentially, you're going to get the same thing. Okay, so that's the purpose of the second part of the line. Okay, so if you want to write everything in one line, you can say I do yeah, I can do either way. So I can do the list comprehension. Okay, the functional value running as a for loop within the line. Okay, or I just do this map. Okay, so that's two different ways to do it. So that's good. Okay, so here map. Just remember when you do the map, then you just need to make sure that the list is on the outside to convert the data structure. And here I'm also thinking what would be different. So yeah, so actually if you want to do a lambda function here, so if you want to do the lambda function right here, then you would just need to also adjust the functional expression, because here every time for x value in the list, right, I can do the exact same manipulation. I don't really need a lambda anymore, remember. So let's say if you want to just get x squared, right, for your inputs to be the new output, right, then you just do x uh extras 2, right. Then here, then what you need to do is lambda x colon x squared. Okay, so yeah, let me quickly copy that, and uh, let's just try this. So let's make it a C list. C list. Okay, so print C list. I'm gonna do x. Let's say x squared. And here I want to just do lambda x colon x squared. Okay. Just remember here for the map function here, I need a functional expression, so I just need lambda there. But here when I just do the wait. Yeah. Okay. Yeah. When I square the function of when I square the input, then I don't really need a lambda there. Okay. So that's a little bit different. And indeed, okay. So I'm getting what I want. All right. So indeed, there are many ways to do it. Okay. So if you want to do something like this, define the function before, that's totally fine. But if not, then if you want to do a lambda function here, then this place you don't really need that lambda there. Just that's the point. Okay. Just that's good. Right. So yeah, and make sure to play with this. Okay. So basically, you're just giving it's sort of like a more efficient way to code your operations. So another example from calculus. So we have powers of 1, 2, 3. So we're doing, okay, what are we doing here? So we have 1, 2, 3. They are the powers that you want to apply to your function. So basically you're saying here, power of I is defining the function x to the I. Okay, so basically power of 1 is saying x to the 1, which is x itself. X squared, so when you have 2, it's going to say I need to define x squared. 3 is going to be defining x cubed. Okay, so now here I'm mapping power of to powers. And so now what's the type? So this is actually a list of functions. Okay, just remember what it does. So power of is a functional. Okay, for every I, it's gonna give me a function. Okay, so 1 will give me power 1 function, function of power function of power 1. 2 will give me a power 2. 3 give me a power function of power 3. Okay, so powers power of acting on the list of powers. Okay, so if I add a 4, that will give me a longer list. So this will give me a list of functions. And of course, if I enclose it in a list. So if I let me comment this out, and let me not comment this. So what's the type of my function list of 0? So that's saying I'm looking at the function list. I'm looking at the 0th index as a function. Okay, and if I look at the 3rd index, that's gonna be another function. Okay, make sense? All right, so now here I can combine the things that I have done. Okay, so I'm doing the derivative of f for all f in the list. Okay, so this is the functional thing that we are talking about. So every function here in the function list, I can do the derivative, and then I can evaluate at a certain value. I'm gonna get the derivatives at 2 for all these functions. Remember what they are. Power 1 is x to the 1. The derivative is 1, right? Yeah, so let me see. Let me write it on the screen for the notes. So the outputs are already here. Okay, so just be reminded, what's this? This is the list, which is something to the power 1, something to the power 2, something to the power 3, and the derivatives are what? They should be 1. Okay, the derivative of x, the derivative is just 1. Okay, x squared, the derivative is 2 times x. Now the derivative of some x to the 3 is 3x squared. Okay, and now I plug in 2, so essentially you'll get 1, and you need to get 1, 4, and 12. Right? And then these are the errors that are resulting from our approximations. So indeed, you see, okay, here you should not get anything special because you are not really differentiating much, but there are computational issues. Okay, so remember the step, the dx is like 0.0001. So that's in the order right here and in the order right here in your degree 2 and degree 3 derivatives. But now for degree 1 derivative, it shouldn't be anything. There shouldn't be any computational issues, but there are. So that tells you indeed there are certain calculations in the computer that are giving you round-off errors for from the float data type. Okay. All right, so yeah, that's pretty much it for today. Just make sure to play with this code because now, indeed, the things are getting a little bit more and more involved. Okay, so we have the functionals that we can handle. Okay, so all right, so let me stop the recording, and of course, if you have any questions, let me know. But otherwise.